Hello, hi, this is Rani Ahmed with you, and this is lesson 9 in how to program using Haskell programming language. And this lesson I'm going to go further in Haskell. I want to talk about something called pattern matching. Okay. Okay. Here we're going to match some text patterns inside our code. Okay. So, and also I want to add that this lesson I'm going to talk a little bit about the conditional statement if then else. Okay, so if it goes like this: if you have something, okay, if it's okay and it works, then do it. Otherwise or else, do something else. Okay, this is clear, of course, but but I want to emphasize on one thing, that in C or Java or whatever those imperative languages that you used to use, usually what you used to do is just, as you see, if x is greater than 3, for example, if you have to write the word, then you write it, then you put the answer of this condition. Okay, maybe you don't have those races, you have begin and end in the same fashion of Pascal, okay, or other whatever those languages are. And then for an answer for this if statement, if x is greater than 3 is true, just print this line greater than 3, okay? And then you proceed with an else, okay, similarly as in the if statement, and then type or print on the screen lesser than 3. And you have the choice that, and it's optional, I mean, to write else, okay, in C, in Java, PHP, TCL, all those. So what's the matter with the Haskell? Haskell asks you and obliges you to use else, okay, and there's no way to run from, or there's no escape from using else. You have to use it. Why? Because Haskell is a functional programming language, which means that for everything you have, it has to be a function, and the function has to take an input and must have an output. Okay, so you can't go without an answer for the else inside the if statement. Okay, it looks strange, but you have to get used to it. Okay, so let me read you some codes that I've written inside Haskell. Okay, so this is test 2 of x. Okay, this is how we write, for example, if x, for example, is greater than 3. Please take care of the indentation. They are very much important. They are like obligatory important. Okay, so if x is greater than 3, then this is how we put then. Okay, this is a print on the screen, put high. Okay, we'll be talking more about the essence of this print screen because this is not really a function. It's what we call later an action. Okay, because functions, it means, like, for example, you have y, okay, equals, this is from math, this is a pure function. Okay, so and this is how Haskell should work, like by natively. Okay, everything has to go with functions, as we know. So f of x, okay, and this is x squared as an example here. So you'll get for every value of an x, you get a y, but for every y you can have multiple x's. Okay, so there must be an answer, and it has to be always the same answer for the same x. Okay, but here in print screen or print line, okay, it's different case because you know, you have different inputs and different outputs. Okay, so just understand that this is how print screen works. Okay, print on the screen works. Okay, print string line. So this is else. Okay, you print by. Okay, and this is test 2. Cool. And also we remember there's guards, okay, the guards, remember that from the lesson of guards. And this is also a different way of talking about if statements, okay. And if you want, we can have also a way to print a function of tuples, okay. Like for example, if I have x here, I can return a tuple of x plus 2 and x minus 3, okay. Now we can also see how important guards are, okay. Let's imagine that I have a fixed number of or like a set of fixed points and fixed inputs, okay. Like for example, if I have x here equals 3, it will give me 10, okay. It will give me for the number 4 20, okay. If it will give me for the number 5 30, and otherwise will give me 0. But if you look at this, it will go like this, go all the way down the screen if you wanna go and continue with this. This is very ugly. So the good thing about Haskell is that we use the pattern matching of functions, okay, which means that when I have test4, let's make another function or having the same meaning, okay. When I have test4, okay, at 3 it gives me 10, as simple as, okay. There's no need for this lengthy if statement, okay. And for number 4 gives me 20, for number 5 gives me 30, and I can go and proceed with test4 of x, okay, with this guard, okay. So I have given like a set of values for the same function where it gives me its corresponding values, okay, the 10 and 20 and 30, okay. And this is the function when I have a range of numbers, okay. And otherwise will give me 0, which means anything else will give me 0. This is what test4 will do. Now I have this line, okay, for a fixed value, which is an alias for the otherwise, the underscore character. So if you have the underscore character, it means whatever, okay. So if you don't have, for example, this definition of the guard, and you want to say whatever else, okay, it will give me always a 0, okay. Now there's also something in Haskell called let binding, okay, let binding. Now what's let binding? Let's imagine I want to talk about the second degree equation, and I want to give the solution for this equation. And as you see, the solution of this equation is two solutions, okay. The first of which minus b plus this radical, okay, we call it the discriminant, okay, over 2a, and the second solution will be minus b minus the discriminant under the radical, okay, 2a. Now I can write the solution as you saw as a tuple, see, simple tuple, similarly to the roots function here, okay. This is just a solution for the real numbers, of course. Now but seeing this is very also ugly, and you have to, you know, put the square root, okay, in a different line, and it's better to put it in a different line. That's why we use this fashion of writing. So I can say roots of a and b and c, okay, will be let the s disk, which means this discriminant, okay. You call discriminant because you know, if this is less than 0, which is under this the root. Okay, you cannot have a real number for a for a square root. Okay, which is a negative number. Okay, it will otherwise go into complex numbers. Now I defined this the discriminant, and I defined also what's under the division as 2a, okay, twice a, and because of this, okay, it's like the opposite fashion of using the where and the function, like we saw in previous lessons. In this, and see, I've put the sdisk here and twice a here. So I'm just defining separately in separate lines, okay, the numbers here, sdisk and twice a. Okay. Now here, this is we'll be discussing in a different lesson too. Okay, and we'll be always using this way of writing the code. This is like in C, you use the main function, or in Java. Okay, this is where the code starts if you want to use it to compile your application, and it uses the command do here, and this is the rest of your code. Okay, and that's all. So let's test the code. Let me load it. Just test.hs. Okay, now if you notice here, like I have an overlapping definition, so I will have to remove the test4 underscore. Okay, so this is roots of 1. Okay, gives me that tuple, which is this one. Okay, and this is the roots 2, which is the tuple 2 for ABC. Roots 2, let's say 1 and 3 and 2. When you have in math, and regarding this equation, when you have A and B together are the sum, A and C are the sum of B, okay, one of them will be -1, okay. Roots, just a typo. So one of them will be -1, okay, and if you want to say like -1 and -2, okay, one of them will be 1, because if you sum them it will be 0, okay. So because of this, you get one of the roots is 1. This is just by memorization, you know, okay, you don't have to recalculate it, okay. And this is roots 3, it's the same, okay. And this is roots 3 for the first one, okay. And let's go for the test cases. Here, if I want to say and see how test 3 and test 4 will work, okay. Test 3 will be for 3 gives me 10, 4, 5, and 6 will be 0. Cool. Now let's use test 4, and this is for 3, 4, and 5, and 6. We made 6 to get at 40 because of this guard here. See, because of this line in the God. Okay, and 7 will be 42. Let's say I have an 80, it gives me a 0. Okay, so that's all. I hope you enjoyed the lesson. Please click on the subscribe button in your channel. Okay, and have fun. Bye.